All right, let's go for number one of the review. So this is evaluate when x equals -3. So if x equals -3, that means everywhere I see an x, it is -3. So the first thing I'm going to do is substitute that in for the variable. For each of these expressions, I substituted in -3 for x. And now we're going to solve using order of operations. So here 15 times 3 gives me 45, but they're different signs and I'm multiplying, so it's -45. And then I bring down the -5. That's as if we're going further into the negatives. A -45 plus another -5, and that's -50. When you evaluate, you do get one number as the answer. We don't need any variables because we know what the variable is. It's -3. For letter B, 3 times 3 is 9, and then I look at the signs, they're both negative, and if they're same sign, then it's positive. It's like the opposite of a -3, remember. The opposite of 3 times -3, that is. Okay, when we add these together, we get +20. And when we look at the last one, just anytime we're multiplying with fractions, if it's an integer, we put a 1 in the denominator. So just kind of picture this as 1/4. 1 times -3 is -3. And 4 times 1 is 4. Plus 5.5. Okay, so here I have decimals, I have fractions. If you're comfortable that 3/4 is 75 hundredths, you can convert that. If not, you could do 3 divided by 4 and you get 0.75, 75 hundredths. So I have a -75 hundredths plus 5.5. And it looks like, oh, please just let me add those. Nope. They are different signs, so you have to subtract their absolute values. So here I have it set up. I'm going to subtract their absolute values. I don't get to just bring down this 5. I have to borrow. Borrow again. And we get 4 and 75 hundredths, but there's more negatives than positives, so it's -4 and 75 hundredths, or -4 and 3/4. For number 2, we have triple the sum of y plus 6 muffins. If we're finding the sum, that's the answer to an addition problem, and the only way we can add before we multiply, because triple means 3 times, is if we put it in parentheses. So I could do this times 3, or I could have 3 on the outside. Either way, you're taking y plus 6, that should be in parentheses, and then multiplying it by 3. Number 3, we're translating and writing an algebraic expression. So Jordan bought B bagels. Michaela bought 6 less than 4 times as many as Jordan. So if Jordan's B, 4 times B, and then take 6 less than that, minus 6. So 4B minus 6. And then if we know how many Jordan bought, we can substitute it in for B. And if it's 9, then we know 4 times 9 is 36. 36 minus 6 is 30. So that would mean that Michaela bought 30 bagels. Okay. Wonderful. For the first step, I just use commutative property to get my like terms next to each other. I like to do that. You don't have to. If I have a -10 and a positive 21, that becomes 11a. Different signs, so I subtract, and there were more positives than negatives. Plus, there's no other b's, so plus 5b, and then 32 minus 32 is 0. So that cancels out. So I have 11a plus 5b. When we get to number 5, these get a little tricky. We're matching these with their equivalent expression, and it's anything that it could be equivalent with. So I'm just going to change these to plus and negative because, yikes, there's a lot going on here. You might think, oh, I need a common denominator here, but -2/3, that's a constant, and a -1/2 x, that is a variable. So this is like having 1x. So if I combine my x's first, I end up with a positive 1/2 x because the other one, the 1/2 x was negative. And then minus 2/3 x, or plus a -2/3. No x, sorry, just minus 2/3. So any of these that are equivalent to that, this one's equivalent, and that's it. For the next one, here I have a positive 1x and a -3/4 x, which gives me 1/4 x positive. and then plus a negative 1/2 or just minus 1/2. So that matches here. And for the last one, I have a positive 1/3 x plus a negative 2/3 x. When I subtract those because they're different signs, I get 1/3 x, but there's more negatives than positive. So I get a negative 1/3 x minus 3/4, or plus a negative 3/4, and that would be here. Distributive property, we're going to multiply the term on the outside by each term on the inside. 2 times 14 is 28, and they're different signs, so negative 28x. And then we have negative 2 times 7, which is negative 14, so I could just put minus 14. If you had negative 28x plus a negative 14, that's fine as well. Here I'm going to combine my like terms in the parentheses first. You don't have to, but I like to. So I end up with 7 times 4x minus 3. And now when I use distributive property, I get 28x minus 21. If you did it by distributing to each of those terms before combining like terms, you should end up with the same answer at the end. For letter C, I'm taking 1/3 of each of these. If I wanted to multiply, I could put these each over 1, but these are pretty friendly numbers. So 1/3 of 6 is 2. They're different signs. If I had multiplied straight across, I would get negative 6 over 3, which is negative 2. Plus 1/3 of 3 is 1. Or I would end up with 3 over 3 if I multiplied, which is 1. Let's use order of operations here. Distributive property, we multiply, so we need to multiply first. We get 2x minus 12. And then 2 times 8 is 16, so positive 16 plus 16. There are no other x's, and then negative 12 plus 16 is plus 4, positive 4. So 2x plus 4. When we add these expressions together, it's a really fancy way of just combining like terms. Here I have a negative 1/3 and a positive 1/3 y, so those cancel out, and I'm left with 6x minus 10. I could have used commutative property to get those like terms next to each other, but it looked pretty friendly to me. So 6x minus 10. Last two. There are 10x minus 8 customers in the store on Monday, 6x plus 16 on Tuesday, and we're looking for the total. So we're going to add those expressions together. So here's Monday's expression, here's Tuesday's, and let's find the total. Again, I could use commutative property, but this one looks pretty friendly. I have 10x plus 6x, which is 16x. Negative 8 plus 16, that's the same as 16 minus 8, which is positive 8. So that represents the total for the 2 days. Here it says find the difference between the expression. The difference between 9 and 10 is I don't get to just start combining like terms. I have to do something first. So let's go ahead and change the sign of each of these. This becomes minus 7x plus 11. Changes the sign of everything in the second set of parentheses. Now I'm going to use commutative property for this one because it's a little tricky. So I have 4x, put minus 7x. I'm just going to put plus a negative 7x. Minus 21 plus 11. When I combine my x's, I get negative 3x. And negative 21 plus 11 is negative 10, or plus negative 10.